Good afternoon and welcome to this webinar. My name is Giuseppe di Modica. I'm an assistant professor with the University of Bologna. And today is my great pleasure to moderate this event, which will address one of the most interesting yet tough challenges for humankind that humankind has been facing and will be facing in the next future. I'm speaking of smart mobility in urban environments. First of all, smart mobility means guaranteeing the transportation of people and goods in a way that is both flexible and sustainable. So people demand for flexible service. They want to have transportation service when it's needed, and they want to get to the destination as fast as possible, so through the shortest possible path. For what concerns sustainability, we have to, let's say, develop services that are sustainable for all the stakeholders. So we would like that all stakeholders' benefits overcome the costs. And that has to be true, that has to apply to all, under all perspective, included the one that we usually refer to as planet positive impact. So today our speaker will present a smart mobility solution that address all these issues, and he and his team have already developed a prototype of their service. They've been testing it in several municipalities, both in Italy and abroad. It is then my great pleasure to introduce Dr. Tommaso Gecchelin, who is the inventor of the next modular vehicles. So, Tommaso, the stage is yours.
Thank you very much. Thank you very much. It's a honor to be here, and I would like to showcase to you already here what it's all about. So what we are creating, it's a vehicle that it's some kind of a minimal unit of transportation, and it's modular. So as you can see in this slide, in this image, you can have one single unit, or you can have multiple units docked together. Each unit is potentially independent, but when you dock together multiple units, you create a vehicle that have not only more capacity, so you can have more people or more cargo inside, but you can also have transfer of people and goods between the pods connected together. So as always, the most important thing is to create something real, because this image is like a future vision of the project. But the project, it's already real. So the first video that it's going to start right now, it's related to the testing, the demonstration and the study that we have done in Padua with our prototypes. And here you see in these very first images the core technology that we are developing, that it's the capability of docking vehicles in motion. So these two units, in the first few frames, they were aligning together and docking precisely with an automated system that allows the vehicle then to be physically and rigidly connected together and work like a longer bus. So it's not like a train, it's not articulated, but to maximize the flexibility of the service in terms of the transfer of people between the pods, we need to dock the pods in a completely rigid way to be very safe. Then in the next slide, okay, there is another video, because it's very important to understand how it works from the passenger perspective. So many people generally see the slides, see the renderings, but they don't really grasp the dimension of the vehicle. Here you see that the vehicle, it seems very small from the outside, but when you go inside, you see that it can host 6 seats, in this case 5 seats, but you can have also a very large space for standing people in the middle. So you can fit up to 16 passengers in just one unit. Here you see the docking procedure. And here you see when the doors between the pods open, allow you to move from your vehicle, let's say the original one, to the next one. So here you see one of the most important feature, that it's the transfer in motion that allows a lot of benefits that I will showcase to you later on. Okay, so back to the slides. Okay. Here a very short introduction in terms of details. You see how a single unit, here you see the unit with the wheels covered, but of course in the first video you've seen how the vehicle can be also with the wheels uncovered, so it seems more like a traditional vehicle. But the single unit have roughly the same capacity for cargo than a small delivery vehicle that can reach the very inner part of the city in terms of cargo. In terms of passengers, we have 5 or 6 seats, but we can also have standing people. So it's very short. It's have the same length of a Smart 4.2 car, but at the same time, in the same length, you can fit inside 16 people because it's maximizing the internal space. All the drivetrain, the battery, the motors, the electronics, everything is under the basement. So the cabin on top of the basement, it's fully dedicated to passengers or cargo. So in 2.7 meters, you can fit 16 people. That it's roughly the same capacity of passengers per, let's say, meter that you have with a city bus, a typical urban city bus. In fact, if you dock together 5 pods, as you see in this slide, you have exactly the same capacity of a city bus, roughly 80 passengers, 29 people sitting, and a total with people standing of 80 passengers. Of course, you can have many layouts, so you can have 2 pods, 3, 4, up to 5 pods. It's legal. More than 5 pods needs to have specific permits in specific roads. But when you have from 1 to 5 pods, you can scale the capacity depending on the need, on the demand that you have at that specific area or time of the day. So this chart, it's very clear. So you see that depending on the time of the day, let's say in this case from 5 a.m. to 11 p.m., you have different demand. So this is the chart. These are the data that the city of Padua gave to us in terms of the demand of transportation that you have in the city. So you see that there is a peak. So the peak hour, it's at 7 a.m. So generally, the entire fleet of bus of the city, it's determined by the peak time. So if in the peak time we need to have one long bus, one, let's say, 12-meter bus, or even a double bus, then after the peak, you don't need that capacity anymore. So basically for the rest of the day, you're using twice or even more vehicle that you really need if you have a modular system. So what we are doing and what you see here, instead of moving in off-peak times, the complete weight, the complete vehicle, a complete 12-meter bus, we're just slicing this bus and moving only let's say, the subset needed to move that specific amount of people. So if you do the math, the consumption, it's lowering a lot. So it's going down 50 to 60% less energy consumption compared to a non-modular city bus, of course. Because if you have, for example, 18 tons of steel and glass that it's moving on the road, even if there are only 5 or 10 people inside, even at night it's even less, there is actually a complete waste of energy. And this is the very, very simple scenario. For example, in this scenario, as you see here, you just need one driver. You don't need many drivers, because the docking and undocking, it's something that it's not needed to happen in real time. It's not needed to happen in motion. It's something that can be done from one round trip to the second or third round trip. For example, the bus can go to the main station or to the depot, and each time it's in the depot, decide how many vehicles have docked together on the back. This can happen in a second, let's say, more innovative step. This can happen in parking spaces during the round trip, during the line path, or can happen gradually in motion in the future. So it can be very flexible today, even with one driver. It can be extremely flexible tomorrow with the driverless technology applied. So here you see some figures. You see how the worst case scenario, this really depends on the consumption of the vehicle itself. So you see that even in the worst case scenario, it's around 20% of energy saving. In the theoretical case, so if we substitute not just 2 units, but we substitute 5 units to a traditional 12-meter bus, we can have up to 54, in some cases up to 60% energy saving. That in terms of economics, it means that compared to a diesel bus, you save roughly 33,000 euros per year per diesel bus substituted with the 5 vehicles, 5 next units. And even if you're using an electric bus, you're saving roughly 15,000 euros. Probably in this period of, let's say, increase the energy price, it's much more than that. So in terms of CO2 emitted directly and indirectly, we are saving, compared to diesel bus, 83 tons of CO2 per year, and 26 tons compared to an electric bus. So this is just by this very, very easy scenario of implementation. It's very powerful, and you're saving a lot of energy and a lot of money. But let's go a little bit deeper in the future implementation, in the future scenarios that entails the use of modular urban vehicles. So let's start from analyzing the geometry of a typical European city, and in some cases also US cities and Chinese cities. So maybe you can exclude only Tokyo and another few cities, but most of the cities have a similar geometry. So you have a very dense center and you have a very sparse suburban areas. What does it imply in terms of public transportation and transportation in general? Well, it implies that it's very difficult to create lines of public transportation that are creating a service that it's ubiquitous enough for the city and the suburban part of the city especially. Why? Because the people are not close enough to the bus station, for example, and so they choose to use private transportation. They choose to use their private car. So 90% of the problem of traffic in the center of the city, it's not generated by cars that were in the center of the city, but they are generated by cars that were in the suburban areas. And since the public transportation is not ubiquitous enough, they are concentrating and they are trying to go to the center of the city, everybody at the same time. And this is because if you need to go from your home to the bus station and then wait at the bus station and then wait for each stop, and when you arrive at your stop in the center of the city, you still need to have some walking time. So this is very uncomfortable. On the other hand, let's say that the taxi will cost roughly zero, okay? So it will be the best way to go to the center of the city because I don't have to own a car. I don't have to pay for the ownership. I summon the car, like Uber, for example. I just order a ride-hailing system, so to say. So I order for the car, for the taxi. The car is coming to my house. It's picking me up, and it's bringing me to the real destination, not to a close-by destination, to the real destination. And at that destination, I don't even have to park the car, to find parking space. So in terms of ubiquity and quality of the trip, the best trip is to use a ride-hailing system like Uber or like a taxi. And the main reason, so to say, why this service is not free, it's not because the consumption or the cost of the vehicle, but it's mainly depending on the cost of the driver. So this is the reason why having self-driving solution, it's the best way to keep these costs very, very low. But of course, this is not something that it's generating only benefits, because if you see this comparison, in one 12-meter bus, you can fit inside roughly 50 passengers, up to 80 passengers in some cases. So you have 4 passengers per meter. In one taxi, especially if you are alone in the taxi, in 1 meter, you cannot fit one person. In 25 centimeters, you cannot fit one person like you did in the bus. So one single passengers are blocking, actually are taking out 5 meters of road. So you have 0.2 passengers per each meter. This means something very important, that if taxi and private cars will become self-driving, the cost will drop roughly to zero. And this means that all the streets will be covered by these single passenger cars. So you are creating more traffic than the traffic that you can cut with the self-driving technology. And this is a very important problem that we are trying to solve, maximizing the number of people that you can fit comfortably in the less space. So if you can have a bus that it's coming to pick you up at home and bringing you to the final destination, well, that's the best case. But of course, you don't need always a bus. You need a smaller vehicle. So this is the reason why we created the vehicle that you just see in the videos, that are very, very small, but they can fit a lot of people inside. So the idea is to pick up the people like a taxi, but gradually going to the center of the city, going into areas that need more capacity, that have higher demand, and that are more congested. We need to consolidate these people in a fewer number of units. To do that with a traditional system, you need to have many stations. You need to have many stops. You need to let the people be very uncomfortable because they need to go out from one vehicle and be picked up by another vehicle. So for example, if you have an intermediate station out of the city in which the taxi will drop off the people and a big bus will pick up many people, well, this is very uncomfortable. And most of the people, unlike most people said that multimodality it's a solution, multimodality can be a solution, but needs to be dropped down to zero, the friction cost for the passengers. And this is how we are doing that. It's something that we can call car jumping. So if we have in close by cars and we are going to the same destination, why do not we jump one on the car of the other, so we have one car with two passengers and the other car it's completely free. So since the other car is completely free, it can go out of the way and, for example, pick up other passengers. Let's think about this car like a taxi. It can go to pick up other passengers. So the problem in this case, it's generally private cars and taxi, they are picking up people, and then at the same time, since most of the offices, let's say, start working at the same time, many people are going to the same destination at the same time. And this is like a definition, by definition, the traffic congestion problem. So if we do this car jumping, we can put many more passengers in the same amount of car. So we create much less traffic in the center of the city with the same ubiquity in the first mile. So the problem is, of course, that with traditional cars, you cannot do that. I mean, you cannot do this in a very easy way, because how can you move safely the people from one vehicle to the other unless you stop the vehicle and you move the people from one unit to the other? But they need to drop off and be picked up again. So it's very uncomfortable. So how do you know on which car you have to go? It's difficult nowadays even to recognize what's the right bus to go in, depending on the destination you have to do. So think about many cars that are switching passengers from one to the other outside. For example, in a parking space, it's very, very difficult to organize this kind of thing. And at the same time, most of the cars that we have today, most of the taxi that we have today, they are designed to fit generally just one or two people. It's very unlikely that a taxi it's comfortable for more than two people. So if you want to fit inside 5 strangers in the same car, it's something that it cannot be done, realistically speaking. So this is the reason why we created a new type of vehicle that, as has been said, it's like a box on wheels. It's not particularly fancy, but it's very efficient because it can fit inside the maximum number of people And these people can freely and safely move, as you see in this picture, from one pod, from one unit, one module to the other, even when they are in motion. So they do not need to be dropped off or picked up again. Everything can happen in motion. Roughly, to grasp the dimension of one pod, it's half the size of a mid-sized car. But in terms of safety, it's extremely safe because the cabin with passengers inside, it's not on the same level of an eventual crash. So, for example, this is the drawing of a typical crash homologation procedure. And the crash homologation procedure have the crash box, the barrier, in the typical position of a regular car. So the regular car will not hit the cabin with the passengers inside, but will hit only the basement of the vehicle. So this is the reason why it's very safe, because the basement, it's absorbing the entire crash energy, and the deformation of the cabin, it's roughly zero. Same thing happen on a lateral crash. A lateral crash, it's generally done for homologation at, you see with the red arrow, the crash line. So the head, the chest, and most of the legs, part of the legs of the passengers are completely out of the way of the crash. So again, the absorption of energy of the crash is being done by the basement, and the people are completely safe because the platform are raised above the basement. So to let's say, to go again on the mission of our company and the mission of this project, it's not to create driverless vehicles, because driverless vehicles alone and electric vehicles alone are not solving the problem of traffic, and they are only partially solving the problem of consumption. The real way to solve this problem is to create a service and a vehicle that can deliver this kind of service, that it's ubiquitous and comfortable as a private car or a taxi, but at the same time can fit a lot of people in a very short amount of space, in very few vehicles, so you can have an extremely efficient way to move these people. Again, you see here a typical taxi, 1 unit. Minibus, it's equal to 2 units. At, let's say, 12-meter bus, it's between 4 and 5 units. And if you want to have a longer bus or a tram, you can dock inside, you can dock together multiple units, more than 5 units, where this kind of thing it's let's say, legally speaking, possible. In terms of moving cargo, you have a minivan, you have a van with 2 units docked together, and you can have a longer truck with 4 or 5 units docked together. This is another video that I want to show you. And this video, it's very important because showcase to you how this consolidation of passengers can be done in a, let's say, semi-dynamic way. In this case, many units are picking up at the same time some people in the suburban areas. In this case, it's a residential area of Dubai. They dock together in a parking space, and this is not happening in motion, of course, as you see here, but it's very, very efficient, and particularly in countries like Dubai or Middle East in general, in which the problem of going outside because of temperature, it's very much an issue. this kind of redistribution of people inside the vehicles, it's extremely important. So you see here that you fit 18 passengers in just 2 units, that it's equal to 12 taxi, that it's roughly equal to 60 meters of road occupied by those private vehicles or taxi. Of course, they can split, and it's important to understand that this is a comparison between our units and a taxi. So in each taxi there is a driver anyway. Even if there is a driver anyway, the benefits are extremely high. You see that the capacity is more than doubled. You see that the traffic has been decreased by those passengers, of course, not in general, but by 88%. And the cost of drivers, it's split between many more passengers. So, of course, you are using less funds, less money. And so finally, the passenger will spend a lot less money compared to a typical taxi. Okay. So 80% less traffic, of course, zero emission, and from 2 times to 3 times the capacity that you have with a traditional taxi service. Let's go a little bit deeper in this explanation, because of course it's not only consolidating the people that are coming from their home alone, but this can happen between lines. This can happen between different, let's say, minibuses that are picking up people that are going to different destinations. Okay, so in this case, of course, you see that the people inside the vehicles are going to different destinations. So if you want to pick them up, there is no way to pick them up with a single unit. If you have a traditional vehicle, you need to have many more units to do this kind of service. Or you need to go to pick up them whole. So you basically multiply the road that you need to travel to pick them up and to drop off them by a certain amount that we will see later on. But if you can have an intermediate point of consolidation and redistribution, and at the same time you have an intermediate point in where you split them after the redistribution and consolidation by destination, you will save a lot of roads and consumption. So this study has been done not only by us, but has been done also by New York University. In fact, New York University did the simulation that you see there on the left bottom side, trying to understand the difference between picking up 4 people and dropping them off, and picking them up, consolidating them, moving them from I to J, and then be split to be drop off in the correct destination. So finally, if you do the math, compared to a Uber scenario, like Uber pool scenario, with this system, you have 48% more profit for Uber, and you have a cheaper ticket for the passengers, roughly 35%. So again, this is a much more simple way to summarize it with just 2 pods, but this is roughly the same, absolutely the same, let's say, rationale. This is again the study, and here you see how they run a lot of simulation with a randomic origin and destination point, and I've seen that on average with regular taxi, the total distance traveled by the entire fleet of taxi to move these people, it's 91 kilometers. If you do the same thing with the consolidation, redistribution, on intermediate point, but without any stop, you have 32 kilometers. Okay, so you have a 60% less traveled road to bring to destination the same amount of people in roughly the same amount of time. So what we did a much more advanced simulation compared to NYU. We did that because actually this is the core software that it's allowing the modular fleet to be routed in the correct way. Here you see how we can put origin points. We put requests of people in a completely real-time way, so they do not need to book the trip beforehand. And you see on the left, you see next vehicles. You see on the right, typical traditional taxi. The same amount of taxi, the same distribution of origin and destination. But the difference is that if you see on the left, that the vehicles are following each other, docking together, and consolidating people. After consolidation, the next vehicles that are empty, they are immediately free to pick up other passengers that are waiting for the service. So the total waiting time, it's dropping, and the travel time, it's raising just a little bit. You see in the end of the simulation that we will have roughly twice the number of people bring to destination in the same amount of time, with a slightly, roughly 5% more time in travel. Okay? So you are maximizing the availability of the vehicle, minimizing the waiting time, and just rising a little bit the total time that you pass in the vehicle while going to destination. Okay, so 400 passengers compared to 246 passengers. Okay, so you minimize the traffic, you minimize emission and pollution, you increase the value of your fleet because you are not underutilizing your fleet with just an average 20% occupancy rate, but you are raising this occupancy rate roughly on average to 75%. And of course, you're creating a service that can be in, let's say, a conservative way, something much similar to a bus line, but you are also, let's say, paving the road to a future service that it's much more similar to a taxi on-demand service. So in terms of a business model, it's something that can be set up in 3 phases. The first one, it can be selling or leasing something that it's like an electric bus, but it's modular, it's more flexible, it gives you operating savings, that it's something, especially in this period, that it's extremely important for municipalities. Then gradually you can do this in a much more real-time way. And in the end, especially for some regions, again, like Middle East or China, something very interesting for the final customer, it's having services in motion that are attached to the passenger pods, the public transportation pods, because the idea is the travel between home and work. If it's taking half an hour, 1 hour, so even for longer trips, especially in big cities, it's a time that it's not wasted, but it's time that you can use in motion and that can bring value to the passengers, but also value to the operators and to us, finally. So let's let's summarize what are generally the competitors that many people thinks that we are similar to. We are not autonomous shuttles. Let's put it this way. An autonomous shuttle, it's like a traditional vehicle, a traditional bus, minibus, with self-driving technology on top of it. It's like that, okay? It can be fancy, it can be symmetrical, but there is no difference on functionality. And if you think that right now, nowhere in the world it's allowed to be completely driverless, of course there is no driver, but there is someone inside that generally it's like an engineer, it's someone that it's supervising the self-driving vehicle. So in terms of the cost of operation, it's much more than a typical bus with a driver, because these vehicles are driverless, but they need an operator, so you need to pay the operator. They are driverless, but they are going to a slower speed, so in terms of passengers per hour, it's much less. So your final revenues from this service, it's very low. We are not a self-driving shuttle. We have a vehicle that it's with the driver right now. If it's in bus mode, you just need one driver for many vehicles. If you want in the future or in some region where the cost of the driver it's lower, to have, let's say, an advanced traffic solution and a taxi solution, compared to a taxi solution, it's much cheaper than a taxi solution, because you are gaining more occupancy rate. So you're moving more passengers in the same amount of time and with the same amount of drivers. In terms of the service, it's something that it's in the taxi scenario, of course, it's more comfortable than a private car. It's roughly have the same comfort of a Uber high quality service. But it's something that it's much less expensive than even than a private car, than the total cost of ownership of a private car. Okay, so let's go, let's say, a little bit in the future. It's something that we have already done in Dubai. It's a pilot in which we were embedding inside some pods services. In this case, it's very easy to grasp, easy to understand. You can place a coffee or a restaurant. You can place some kind of vending machine, smoking pod. You can place any kind of service that you generally use when you are, let's say, in a static environment. You can use it in motion. Okay, so the complete geometry of the city can change, and this kind of service can come to your house or be integrated in the public transportation system. Of course, you can move, as has been said before, people and cargo, or you can move them together in something that we tested in Padua, that it's called cargo hitching. Cargo hitching means that you have a bus, you have something that is moving passengers, but at the same time it's hooked up, it's connected to a vehicle that it's moving goods or packages. Something that it's very interesting in the logistic and the cargo movement, freight movement, it's how you can collect, organize, and dispatch without the need for intermediate warehouses. So now there is another video. Okay, there should be another video, yes, number 5. that it's related to how it happens if you want to use this vehicle as an integrated cargo delivery system. So of course, within private areas, they can work completely driverless. So if you think about a multi-warehouse facility area, you can dock them together completely autonomously. When they are in the middle of the public road, you need a driver, human driver, but something that it's interesting is that a local distribution shuttle, so it's always the same vehicle, it's not different from the other one, but it's coming from a local area. It's docking together with the main truck, so to say, that it's not really a truck, but it's many next pods connected together. Then of course you can exchange the packages. You can do this redistribution in motion and then deliver the package to the final user without the need for logistic warehouse in place to distribute the goods from one truck to many small vans, delivery vans. This can happen, of course, when you're entering a big city. Okay, generally, on the edge of a big city, you have huge warehouses in which you collect goods from a big truck, and you distribute these goods on many smaller trucks, many smaller delivery vans. And this is the only way that you have to distribute goods in the center of the city. This is extremely time consuming and this is extremely expensive. So what we are doing here is we are moving the warehouse itself in motion. Distribution can happen in motion, and so you're saving a lot of money. Another interesting video related to how we can imagine in the future the experience of going to the airport. Actually not going to the airport anymore. You do not need anymore to enter the terminal, so the airport itself. You just go through directly and you go to the airplane. In fact, you can, since you can place inside the pods services, you can dock these pods to passenger vehicles that are going to the airport. These people can use the service. For example, in this case, it's a safety gate and drop off for baggage. You can use this service. You can enter the back of it. So you can enter the pods that are hosting, that are collecting the people that already did the check-in. You can dock together with these pods also duty-free or targeted service pods. And these pods are bringing you directly to the aircraft. This is quite interesting because you see that most of the service that you generally have in a static place, the airport, in this case, they are bring to be completely in motion. You see, for example, you understand, you grasp the value of it, the premium service in motion and the cut of the waiting time to go to the airplane, to embark the airplane. It's something that it's for, especially for premium service, it's extremely valuable. And you see there is no stop by to the terminal of the airport. The embarking, it's immediate. So you save from 1 to 2 hours of waiting time. And the same thing, of course, can happen in reverse when you arrive to the destination, because the passport check, e-gates, security scanners, all these facilities that generally are inside the terminal, in this case, they are put inside this as we call rooms on wheels, like boxes of space, empty space, that can be fit with any kind of high level and important services. So if you can go back again to the slides. Let's go to, let's say, a little bit more on topic at this moment, especially a couple of years ago. The importance for public transportation, especially, to create a system that it's very safe for health of the people. So, COVID-19, it's moving a lot of people from taking public transportation services to try to be safer and take their own private cars. So, think about 4 passengers divided into 4 private cars. Okay. They occupied roughly 25, probably even more space on the road, 25 meters, linear meters of the road. At the same time, even if we want to put just one single passenger in each next unit, so 4 passengers inside 4 docked units, the total length of this vehicle, it will be roughly 10 meters. So we are saving more than 60% of road. So even if we want to completely separate those passengers, closing the doors in between the pods, we are saving a lot of traffic. Here's some technical specification. I mean, if you have curiosity about it, it's of course an electric vehicle. The range can vary from, let's say, 100 kilometers to 300 kilometers, depending on the battery pack. It's important that these vehicles are allowed to swap the batteries, so you can recharge them on regular charging spots, or you can swap the batteries with a very, very easy procedure with a forklift or a pallet jack. You can do that in a couple of minutes. So you can choose to recharge the battery and wait for hours, or you can just switch the batteries and recharge the battery on a shelf with a low energy and low consumption charging system. That's quite interesting because you can have 2 different let's say modules of it. You can have the standard one that it's for flat cities, flat city centers and slow speed, or you can have the powerful unit that can go to higher speed, it can go to highways, and it can also climb, so to say, steeper cities and roads. So let's just showcase the last video, the 7, that finally showcase to you what's the experience of a passenger. Here, this is actually a virtual reality video that it's a little bit difficult to grasp on a 2-dimensional representation like that, but we will probably share the link to enjoy the video with your VR headset. So you can enter the vehicle, ordering the vehicle like a taxi. Here you see how you are alone, basically. There is a very high chance, high probability that you are alone in the first mile, especially because you are being picked up like a taxi service. So, and you are picked up in a suburban area, so there is a very high chance that you are enjoying the first part of your trip alone. but the first part of the trip will cost roughly the same of a taxi. But since most of the trip is being done in a main road, on the main road there is a equally high chance that you find another next unit that it's sharing with you the destination. So you will see in a few seconds how this taxi, so to say, it's going to dock with another unit. You see here the docking. And in that unit, you find already people that are going to the same destination that you have. So this is like a shuttle taxi. It's going to do some kind of relay race. It's picking up people, moving these people to the main road, docking to another unit that it's already almost full of people going to the same destination, and then going back to pick up other passengers. So here you see that once the passenger it's taking a seat, the vehicle on the back doesn't need to be docked anymore, so it detaches and go to pick up other passengers in the local areas. That's something that it's exactly the same as we have seen before with the simulation, let's say map simulation software. This is how it looks like when you are inside. So the transfer between one vehicle, one bus to the other, or one taxi to the other, it's something that happens completely in motion without almost any stress for the passenger itself. It's really a matter of stand up, walk 2 meters inside the corridor and take another seat. So it's like in a bus if you change from your seat to the seat in front of you. Of course, when it goes to the destination, it can detach from the rest of the bus and go to the desired destination. It's quite hard to see, but of course all the notification has been given by the phone. And there is a tracking system inside, so if you're not in the correct place, there will be notification on your phone and notification from the speakers inside the vehicles. So it's very hard for people that are not completely dead or sleeping to make a mistake inside. So thank you very much. I'm quite much open to any question, online and offline.
Much, Tommaso. It was quite an interesting talk. So we're open to question, as our speaker said. Please post your question on the chat, on the public chat. So I will take questions and we'll pass them to our speaker. While audience posts questions in the chat, I would like to ask you, I have some curiosity, a question to ask you. Let's assume that your solution, your service will be successful in the near future. So what, let's project ourselves to the future. What do you think, the future of transportation, what will it be like according to your vision?
Thank you for the question. So I think that there will be some kind of polarization of the market. So if you think about when we transition from horse and carriages to internal combustion engine cars, okay? In few years, there was a radical change, not only on the street, but on thinking about what a horse can do. Okay, so now let's say a city car, it's not something that we really like to drive in the traffic each morning, for example, but it's something that it's more like a mean to an end. Okay, it's just to move from A to B. On the other side, there are many cars, but fewer number of cars, that are cars that you really enjoy to drive and you buy because you want to drive those cars. So it's like riding a horse. Okay, so this will be roughly the same transition. If you just need to move from A to B in the morning, like commuters, you can have this kind of in the future self-driving, but of course, let's say smart solution, modular solutions that allow you to go from your home to work, to school, or to the main train station. On the other hand, the polarization will cut the middle part of the market. So the market that now it's related to city cars and very cheap cars. But the high end of the market, the cars that are for sport purposes, they will remain. And probably that market will raise a lot from the level that it's now. So for example, I envision that Ferrari, Porsche, and these kind of cars will increase their markets. But companies that are only making city cars, they will see a very huge decrease in the market share. At the same time, of course, probably because of Next, I hope, the public transportation will be much more comfortable, and so the people will prefer to use this kind of service instead of owning a car.
Thank you very much for your answer. Let me check if there are questions. Not at this time. I've noticed that it's a question about the shape of the dog. So I've noticed it's not just a box in the full sense of the term. I mean, it has a kind of sloping sides. Is there any reason for that? I mean, it's just a design thing, or is there a reason for this specific shape?
Sure. No, it's not a design. I mean, if you think design like style, it's not that. If you think design as engineering in a much more deeper sense, yes, it's design. It's design because you have three main advantages of that shape. First one, it's you have less drag, aerodynamic drag. Second one, it's that you move the, let's say, the center of gravity of the vehicle slightly to backwards. So it's less likely for the vehicle when braking to tip over. And it's the same tilt, the same inclination, the same angle of a typical city bus seat. Okay, so if the vehicle were a complete box, you can fit less seats inside. So with this shape, you can fit the maximum number of seats possible inside. Okay. So that's the reason why I had that
that's
shape.
The reason. Thank you very much. Let me check once again. Okay, we have a question from the audience. And the question is, do you think it is possible to private modules to attach for a part of a travel to public modules?
Yes. Actually, I've just been present to a master thesis of a student from Turin that was making, let's say, the interior design of private modules. So how it could look like a private module. So a private module with this kind of shape, it can be a part of a recreational vehicle, for example. So you can have one unit that you use day by day, maybe to go to to work, but you can dock together, renting them units with a kitchen, with a bathroom, with any kind of service that you need to go to a specific vacation or a round trip. So it's quite interesting. Of course, this completely private scenario, but it's also interesting to see how it merges with public scenarios. So if you can have a vehicle, let's say that head vehicle with a professional driver, and have many private units docking together to create some kind of a road train, of course you are saving less energy compared to what we have seen here, but you are having a private slash public scenario that are making an optimization, a low-level optimization, keeping the service very comfortable and private in this case. So it's, of course, it's possible. In terms of legislation, this is not something quite straightforward. It could probably, it would probably be difficult to implement in terms of, from a legal perspective, but it's not something completely crazy.
So, for what I'm understanding, much of issues that you're facing doesn't come from, I mean, technical matter. It's just, I mean, legislation and all regulation that, of course, it's hard to.
Yeah, it's in some way it's comforting because it means that it's something new. Okay, but it's also very complicated because you need to make this thing fitting into the legal boundaries that are meant for vehicles that was designed 100 years ago or 50, 60 years ago. So this is something completely new in terms of the shape, but especially in terms of the type of service. Docking together vehicles, it's something that happens, of course. It's not the first time that vehicles can dock together, but not in this way, not rigidly, for example. So you're changing the type of vehicle dynamically, and this is something that it's quite tricky to fit into the legal framework.
Okay, so you showed us that you still need drivers to drive dock, of course.
Yeah.
If you want to keep flexibility, of course, you have to have one driver per dock. But do you think that maybe in the future, I don't know, according to the business model that you want to enforce, private passengers to be able to drive this dock, and maybe, you know, you provide them with incentives, and they could be the drivers for this kind of modular.
Yes, you can call it like a Uber-like scenario. In fact, I always said taxi and Uber at the same time because it's not needed to be a taxi driver hired by someone. It can be a pro user, so to say. Okay, so this user can, for example, think about when you're going out of work. You're jumping into a bus, and then the bus is making a lot of stops. Okay, now think about when there is like a splitting point, and from that point after, you have inside less than 9 passengers in each unit. So each unit, it's formally an M1 vehicle, means that with B driving license, so a regular driving license, you can drive it. So one unit, you can drive one unit alone. So from that point after, so for the very last mile, the one passenger itself can drive the pod from that point to the destination. And this will decrease the cost of operation and the cost of the ticket, so to say, even more than that.
So it could be a possibility for.
It could be actually this possibility. It's something that it's not that futuristic.
Okay. So it's been explored some way.
Yes.
Okay.
Yes.
So, do you have any rough idea of how many of this modular dock you need to cover a big city like, I would say, Milan or New York? Any rough idea? How would you dimension this number? How would you do that?
We have done, we have dimensioned a fleet to cover completely the city of Padua, that it's roughly 200,000 people, and it's 400 vehicles.
Okay.
So with 400 vehicles, so let's say that with you can think about cities, so 200 vehicles each 100,000 citizen.
But it's also a matter of the geometry of roads.
It's
right?
also a matter of the geometry of the roads.
So it's
Yes.
not just counting how many people do live in that places, but also you have
Correct. You need to have a city that have the shape that I've showcased to you. So, for example, I've met a guy in Tokyo who said, no, in Tokyo it will never work. I agree. In Tokyo, you have a huge public transportation infrastructure. You have probably the best public transportation network in the world. So there is no need for next. Okay? We don't care to go everywhere. We care to solve real problems of cities. In this case, for many, many cities in Europe, that's the problem. Most of the traffic is generated by commuters that are coming from very suburban areas with the public transportation closest station that it's more than 1 kilometer away. That's the...
Yes, I see the point. We do have another question from the audience, which I'm going to read. It's about the schedule algorithm, and they are asking if this algorithm is optimized for the shortest path or to maximize the number of people. And the second part of the question is this statistical or can it change dynamically during the day?
It can change dynamically, and not only during the day, but during the same trip, or depending on the preference of the user that booked the trip. So the application is done this way. So you choose to go to a specific destination, and then you choose how you want to go there. So for example, let's say that I absolutely need to make an important call. So I want to go there, but I want my pod. I don't want to share the pod with anyone else. Okay, so in that case, I choose privacy setting, and the estimated price of the trip has been showcased. So dynamic pricing and the options of trip, it's something that it's very intertwined. So it's something very important, because if you have, for example, the closest pod, it's very far away, so you give to the user an estimated price for that trip extremely high. So there is a very low incentive for this person to pick up that means of transportation.
So the price is dynamic anyway.
The price is dynamic, and the system is dynamic. So also the, let's say, the cost function that it's at the base of that algorithm, it's changing from time to time and depending on the type of request.
And that stimulates another question on my side. How huge is the effort of managing the fleet? I mean, there has to be some kind of back-end information system, and you have to handle all this information, make things correctly run. I mean, there could be also people watching and taking care of everything. So there, apart from, of course, the prototype that we have seen, there is a back office that you have to set up in order to handle this fleet.
Yes, correct. Yes, I mean, it's not that much more complex than bus fleet management or cargo fleet management. Of course, you have another layer, but most of the operations are automated in the back end. So, yes, it's not that much more complex than a typical fleet management system.
Okay. We have one more question from the audience. How about incentives for people to move across different modules? And do you have to give them some gentle push? That's something that...
the incentive, it's like when you take a bus and not a taxi. The incentives is because you pay less. Okay, so you can decide to pick up to order for a limousine to bring you to the destination, or you choose to go to the bus station. Of course, it's always a matter of balance between the comfort and the price. In this case, the people that do not want to pay for a limousine, but they do not want to pick up a bus 2 kilometers away from home, they basically say, okay, a good alternative, a good compromise, it's that I've been picked up like a taxi, but in the middle of the road, I just switch from this place to your place. So it's like very standing and sitting to another seat. So the stress of me moving from here to there, it's very low. It's almost negligible, so to say. Of course, it's less than walking 2 kilometers away. So this is the reason why. It's a good balance between the demand and offer.
Okay, thank you. I think we have room for one more question, if there is any other question from the audience. Yeah, that's a very long question. Or so somebody saying that it's a very interesting talk.
Thank you.
Thanks a lot. They know that a few days ago on Monday, Taliban was awarded here in Bologna at the important conference, and he delivered a keynote, a speech, where he made this provocation. So with a lot of vision of possible futures. And I remember I attended this this keynote. So one of those was exactly in the direction of Next, the one that you are trying to follow. Yes.
Okay.
And he was predicting that in the future there will be no cars. Looking at the presentation, they are wondering if you thought about the impact of your solution in terms of workforce and the emergence of new types of work, new types of job, I guess. And how about the city economy? So no more cars, no more parking lots. You don't need parking spaces anymore, and no more fees. So there is this kind of vision. So you don't have cars, and there is a kind of change in the economy. And so they ask what do you think about, what will be the new workforce that you have to put in place in this vision?
So it's, yeah, I get the question, and I'm a little bit less, so to say, futuristic. And I think that anyway the cars will not disappear. They will not disappear, or maybe in 200 years they will disappear, but maybe in 200 years will be...
As long as we need to move.
I don't know, we will be brains in vats and let's say filled with simulations and stuff like that, I don't know. But in the next 50 years probably, the cars will not disappear. Many cars, and probably also internal combustion engine cars will stay. And most of the traffic, it will be with drivers. So I'm very skeptic with visions that see a radical change in a few years. We have seen that 10 years ago, 15 years ago, Google said, okay, we have the technology for self-driving. Today, you don't see any self-driving level 5 car on the road. Okay, maybe it will be exponential, but it will be an S-curve. So it will stabilize. There will be like a ceiling effect. So it will remain like 5 to 10% of the private cars, maybe those sport private cars. But there will be roads, there will be cars, there will be buses, there will be a lot of conventional vehicles on the road. So what we are trying to do, it's not to revolutionize, but it's to optimize and to be very flexible and scalable, so we can implement this vehicle today, we can increase the functionality and the optimization level tomorrow, but we are not trying to get rid of the cars all over the place. So in terms of work figures, I mean, even if you have, this is always what I say, even if you have vending machines, okay, and even if these vending machines can deliver to you almost anywhere, I mean, theoretically speaking, you can go to a bar and instead of taking a drink, that drink can be given to you by a robot or a vending machine. But it's not like that. I mean, it's full of people working in restaurants and bars, even if technically speaking, it's not needed. So I think that the work of the future, it will be different, but not in the way that we think today. It will be something probably much more similar than is today, and for some works, completely different than things that we can even imagine today.
Okay, and assuming you're right, and your paradigm that you're trying to enforce will be successful, are you scared about competitors? I mean, they will try to organize themselves and imitate your solution. How about that? You mean?
Right, so when you talk about innovation, it's always a matter of speed of implementation, and something that it's quite interesting, it's when you see something like Facebook and Google, okay? Facebook became a huge company, a huge service, even if Google was already capable of doing the same thing.
They missed the chance to become the social.
And in that case, it's not even a matter of hardware.
I know.
Because you put the software, you have the user base, so it's a matter of 2 days of development.
Yeah.
And in that case, a company that doesn't have at that time any intellectual property did a huge success compared to a big company like Google. So in some cases, especially in cases with this kind of technologies, if you have the right speed and let's say the startup mindset, you can reach a huge market even if the big companies are, let's say, have the possibility, have the assets to replace your idea quite easily.
And my next question is, I want to provoke you.
Yeah.
Do you have any exit strategy? I mean, exit strategy.
For the company? Or?
Yeah, for the company, I mean.
No, of course, these big companies, in many cases like this, they say, okay, I stay here, I have a huge pocket, I see if this thing works, and when it works, okay, I just buy it. Okay, so yeah, why not?
Yeah, of course, of course. It's understandable, of course. Okay, I don't know if there is any other question from the audience. It seems there is not, so we are almost on time. I thank you again very much for this very interesting talk. It was, I think it, and I hope it was of inspiration to me for sure, and for the audience as well. And we look forward to seeing those next modular.
To have a ride
I can wait to use them, because I do believe that it's a smart way of moving people and goods, as you explained to us. So thank you very much. This concludes this talk. Thank you very much to the audience as well.
Thank you very much again.